Hi everyone, welcome back to another BTLO Replay. Before we jump into LOGGER, be sure to follow us on X, LinkedIn, or join the Discord server to keep in touch with the BTLO community. Links are in the description box below. Right, let's get started. So imagine if you are a part of a busy finance team, juggling numbers and invoices. One day, you discover a strange file in your system. It's unrecognizable, unexpected, and potentially dangerous. Such scenarios, stakes are high. Keyloggers can steal sensitive information like passwords and financial data. So, but first, what exactly is a keylogger? So, in simple terms, it is a type of software designed to record your keystroke every time you put something in it, the keyboard, right? It could be secretly log and send someone with not so good intentions. So, yeah, let's get started. To analyze this mysterious file, we'll use specialized software tool. These tools can peek inside the file and tell us what this executable really up to. Start. So we have here inside the malware sample directory, we have a cab voice.pdf. So in the normal eye, especially if you're a non-techie or just like doing your day-to-day tasks, jobs as non-IT personnel, will find this file benign, right, or harmless, right? But um, let's see if let's see some red flags just by looking at it. So we have cab invoice.pdf, right? It's benign, it's harmless the way we look at it. So one of the red flags we can see here is that it's a PDF file, right? So it's a PDF file. We know it's a document basically. So, but if you look at the type, it's an application. It's an application, and also the size. Size is 7 MB, 7,000 KB, which is quite big enough for a PDF file. So, what are we going to do next is that we're going to reveal the hidden file extension. Do it by view, not the hidden items. Let's go with the options, change folder and search options, view, show, hide extension. So here we can see that cab invoice at PDF is not an actual PDF file, but it's an exe file. So we will be using this one as our sample to answer this series of questions. What is the MD5 hash of the malware sample? What is the compiled date of the malleable? What is the programming language? So we're going to start by answering the question number 1. What is the MD5 hash of the malware sample? We're using here, we have to open to answer question number 1, which is asking for the MD5 hash of the malware sample. We have two choices here. So either way, we can get the answer a different way. So either we're gonna use PowerShell, and use the get file hash get file hash, algorithm, sample, and here. So this is another way of gathering the hash value of the file itself. We have here the hash calc, which is indicated as we dive into the tab investigation. We're going to drag or navigate to the file itself. With that, I can calculate. See, it's the same. Either way, you can get the answer to question number one. Found the hash value using different. Copy this one, paste. There you have it. We have answered question number. So what is the compiled date of the malicious sample? So what are we going to do when we are analyzing a malware sample? Is that we don't want to analyze the malware sample like directly, like running it directly. If we can gather information about the sample or the malware itself through static analysis or not involving the execution of the sample, it's easy, right? So if static analysis alone does not provide any valuable information, such as gathering IOC for creating rules for your antivirus software or any kind of stuffs, then the dynamic analysis of the behavior analysis of the sample is needed. So as long as you are exposed to a malware sample that you are about to analyze, just first start to do it statically or without running the sample. What is the proceed with question number 2? Is the compile date of the malicious executable? So we have the format here, day, month, year. Let's take a look at the tools available to us. That toolkit. Here we can see PE view. So let's run this file, executable. Accept. Then let's open the file here. So PE view extracts the PE header or the metadata inside the PE header of the executable or the file. We can see here that it is a MZ 4D 5A or 5A 4D. This is a DOS. It will run in a Windows machine. So to find the compilation date, getting it right, the compilation date. Yeah, the compilation date of the sample. Let's navigate to optional header or the file header itself. So we here we can see the date timestamp. So this indicates that this sample was compiled at this exact date and time. Easy, right? So I'm gonna use that as an answer. Day, we assume that the day is 13. 13. Month is 1. And 2020 is what we've expected as the answer. So what is the programming language used to create the keylogger? So for this one, you don't need to execute the file. Just have to look for strings that indicates it's what program or what programming language does it use. So here we can use the other tool like EID. EID is a well-known static analysis tool. Drag it or open. Here you can see nothing. So supposedly this the answer will be stated here. Let's try our we're trying to answer the programming language used to create the keylogger. Okay. For this one, there are tools. There's a lot of tools we can utilize to answer this question. We're going to use a specific tool which is really helpful when answering this type of question. So what are we going to do is we're going to use strings by sysinternals. Desktop. What we're going to do is we're going to launch strings toolkit sysinternals strings string 64, then navigate to our sample, then file itself, then save it as a text file, string invoice, right? The text. So going to run for a bit, then here you can inspect the file, try to open it. I think I have strings PDF the text correctly. Run it again. You run it again. I don't know why the first command doesn't work, but we managed. Here we have the strings of the samples. We're going to look for strings that correlates with our question, which is finding out what programming language is used to create this executable. So we're going to navigate. So here we have found interesting strings. We have found error, restore, execode, import. So basically, we have found our answer. So here, Python. The format is programming language, Python. Then we're going to proceed with protocol use. Python. Let's go back to this question later on. So in order to find out the protocol, since if you are familiar with network analysis, or we call this one networking, protocol is part of the network traffic, right? So how are we going to find out if we don't run the sample? So our next step is to execute the sample and record the malware, the network traffic. First, we're going to execute this one. reg shot. We don't want to miss out anything uh, uh, that's modified in the registry. So first shot, we will take that as a base shot that will be used to compare later when the malware sample has successfully executed. Take shot and save. Take a little bit of your time. Here, our first shot has been finished. Let's say invoice reg shot 1. Then save it. Now, for the second shot, we'll not take the second shot now because the malware sample is not yet executed. So, what are we going to do next is running procmon 64. Run. It will automatically run in the background. So let's hit Control E, stop capturing. Then stop, then Control X to delete it. Right. So we have a we will use this process monitor later on, right before we execute the sample, because if we use it now, it will populate it with changes in this machine which are not relevant to analyzing the sample. Although relevant, but it populates it to populate the results, makes us harder find our specific answers. The next one, this dynamic analysis, is we're going to execute, going to run Wireshark record, or to capture the network traffic when we execute the sample. So here we have finally launched Wireshark. We're going to use the Ethernet tree because this is the traffic. This is an indicator that there is a network traffic going on the Ethernet tree. Use this one. Since the box has no internet or something, but it has a traffic to connect with the server. So just leave it for a bit, then we run this one. We Control E, then do the malware sample, and double click this one. So what we did was to we execute regshot to capture the clean state of the registry, and then we run process monitor for any indicators of changes in the system, not only in the registry but in the file system itself, and Wireshark to capture the network traffic. So here we can see that this cab invoice at PDF.x is executing. So just wait for a bit and see what happens. So have to run. Wait for a bit. Allow the sample to run background. Then the next question is, what protocol is used to send logs via email to the operator? So since we have an idea that this is a keylogger, we filter for DNS for any extraction. Then use this try BTLO apps. Try if it captured. Look for have here is we can see here that it connects to as SMTP Gmail with um the unknown means it contacting with um try this follow X. Uh, this is really not normal because this machine does not any we don't have any actions that um connects to this to Gmail, right? So we don't open the browser stuffs, but it has something. SMTP is protocol. Try. I think the example is when we type something in Notepad or any keystrokes, it logs it and send it over the internet. Yep, you got it correctly, as we expected. So let's proceed with question number 1, 2, 5, 4. This is the name of the system process the malware imitates to try and hide in plain sight. So to answer this, we're going to leverage tools that we've run before the malware sample. So we pause this the proc1. Then remember when we execute the first shot of the reg shot application, we're going that we're since the malware or the invoice that exe that PDF that exe is successfully executed, successfully run. We have now we can take this second shot. Will take a bit because our registry hive now is populated. I take a while, and we're going to save it. Change, save, then will load, and then we can see here the compare button. So using this button to compare the first shot and the second shot, which indicates that if there are any changes from our base shot, which is the clean shot, the second shot will reveal it. We have compare it in order to find some odd looking strings inside the uh, registry where after the malware sample was executed. So we broke our reg shot. Doesn't have to try it again. Shot. Don't know what happened. Usually we compare quite easy. Have to wait. So we are now about to take the second shot. So shot. So what happens here is the our first shot or the base shot or the clean registry high will be compared later on for the second shot right after the malware or the cab invoice PDF that exe is executed was executed. So this might take a while because it will count all the registry modifications, the keys deleted, inserted, added, and stuff. So yeah, hang on a minute. Once completed, we hit the button compare, then wait for this to complete, and a text file will open in Notepad, showing the added and the deleted registry keys between the two snapshots. So here, back to the question. The question is, what is the name of the system process the malware imitates to try and hide in plain sight? So what we have here is we are tasked to find the legitimate looking system process that the malware imitates to try. Okay, so we have here the notepad. Let's try to, since it's a process, we assume that it's an exe file. No, it's not. For that one, here. Notice that we have svc host.exe, right? So, so how do we know if this is the system process that we are looking for? And how do we know if this is malicious or benign? So there are a few things to look for if you are hunting for a malicious process. So since svc host.exe is a legitimate process in all Windows systems, we don't uh, we don't really see the difference between the same name, right? But all svc host.exe is was residing in system 32. So system Windows system 32, yeah. So for this one, we can see here that this svc host.exe is not inside the ultimate directory, Windows directory. So instead of Windows System 32, it is found in users BTLO test, app data, and roaming. So this is a red flag for this process. Then we can assume that this process mimics the legitimate Windows process, but there's a red flag in the directory. So yes, we have our answer. Let's try to answer the process. The format is process name that extensions. You have to write svc host that exe. Yep, you got it right. Then the next one is, what is the name of the registry location used to maintain the persistence? Okay. So to find this one, since we are using regshot, then this notepad is a populated with registry hives. We are going to look for this one, the same string. It looks like the svc host.exe was added as a subkey, or what do you call this one? A value for this registry hive. Software Microsoft Windows current version run svc host. So back to the question, what is the name of the system process? Oh, what is the name of the registry location used to maintain the persistence? So registry key name, we find it here. So run registry key is common for malware because whatever is inserted into this registry key will be executed during runtime. So it is popular for almost most of malware author to use this registry key to maintain persistence on the system. So let's try to drag this one. Copy, or if it doesn't work, right? Yep. So we have answered it correctly. So what is the malicious actor's email address and associated password? To do this, since we've already executed the cab invoice that pdf.exe, we're going to open Process Explorer 64 in this internals. Run as admin, then look for our malicious process. So let's create a full dump. and save it in desktop. Okay, to dump. That um we've already tried and not working. We have to change the Process Explorer 64 to Process Explorer. Then do the same action. Create the cab invoice PDF.exe, right click, then create a full dump. Then here it is. So our next step is to, since we are tasked to identify what is the malicious actor's email address and associated password. We're going to run strings um, that dump process, right? Open this one, then run strings. Strings, this one, use the copy. It internals, strings, string, then locate the tab in dump. Save is dump that text. So run it again. Again. To use. Oh, okay. Here's. So my bad. But okay, let's do it again. It's is internals, strings, or then the cab invoice. Dump it like invoice. Dump that text. Agree. Here, you can open this one for interesting strings. Nothing. Okay, let's run it again. Again, delete this one. Strings. String 64, right? Cab invoice PDF that dump. Try it again. Here, you can see that we have successfully downloaded or dumped the strings. So let's look for after the question. So what is the malicious actor's email address and associated password? That's for C. Username here indicated. You can look for, let's try to look here. Going back at the top, you can see a very interesting string, act now logger. You can see here the keylogger. This is, we believe, the username and the password. Copy this one. Copy since the question. Then submit. Yes, we got it correctly. So the last question: how many seconds pass before the malware email the latest collection of keys? So believe this is the seconds. So 120 seconds, 2 minutes. Try to. Yep, we got it correctly. I guess you've learned something from this walkthrough. And this is how we analyze the malware, doing both statically and dynamically. There are a lot of malware you can try and same approach and get some IOCs using by what we've discussed in the lab. So that's a wrap. Thanks for watching, guys. Be sure to like and subscribe to never miss a video. In the meantime, remember to join us on Discord and tune in every Friday at 6 p.m. BST for BTLO Replay. Thanks everyone and see you next time.